So we would study it later, but you know too good. Better only, right? No need. Why should we use that GP formula, right? When we know we can calculate faster.
Yeah.
So we would study it later, but you know too good. Better only, right? No need. Why should we use that GP formula, right? When we know we can calculate faster.
Yeah.
What do you think should come here after 4 pi by 7? Tan of what?
As in,
Okay, nothing. Solve this, please.
yeah. God. I'm pretty sure I've seen a question like this before.
Hmm.
Is it? Wait, let me check. Okay, so give me 1 second. I think I made an error. Is it -7?
-7. I think
That
should
feels
be
wrong.
correct. No.
Oh,
Should be correct. Yeah, -7 it is.
okay.
S2 would be 1 minus a minus. How do you do it?
So basically, like, there's an identity, right? Like a plus b plus c is pi. Then we know that tan a tan b plus tan a plus tan b plus tan c equal to tan a tan b tan c.
Yeah.
So pi by 7 plus 2 pi by 7 plus 4 pi by 7 plus 7 pi by 7 equal to pi.
Mhm.
So letting that be a b c, we have a plus b plus c is pi. So that means tan a, and so tan a tan b plus tan b tan c plus tan c tan a equal to tan a plus tan b plus tan c. From this
Mhm.
identity, then we get tan a plus b equal to tan pi minus c equal to tan a plus b equal to minus tan c. So we can take tan a plus tan b by 1 minus tan a tan b equal to minus tan c. And then we can get tan a plus tan b plus tan c equal to tan a tan b tan c. And then we just put uh, tan pi by 7, tan 2 pi by 7, tan 4 pi by 7 is root 7. So yeah, it's -7.
Very
It
good.
is, yeah.
Okay. I think one last question I want to do of this topic. Yeah. Range of x plus y, 1 minus xy, 1 plus x square, 1 plus y square, x comma y belongs to R. Okay. So when we look something like a plus b upon 1 plus a square, right? Or let's say 1 minus xy upon x 1 plus y square. So we try to think about letting x as tan alpha, let's say y is tan beta. Another idea is because x and y are belonging to all real numbers. We know tan alpha and tan beta also have the same range, right? Okay. And also note that such cases, one question we did yesterday also. So here x and y are independent. Sorry, are independent variables here. Okay, but separate them as two different variables. That also has its own advantages. So this becomes what, tan alpha plus tan beta upon 1 plus tan square. And oh wait, yeah. So basically it's becoming
Can you give me 1 second? I'll just be back.
Hmm.
Yeah, we can continue.
Okay. So I wrote everything in terms of sine and cos, and after that we have to just simplify. So I think when you simplify it, you will get something. What will you get?
Do you want me to know?
Yes.
I'll take a second. Just like a bit more. It's kind of long. Is it
Okay. Let
is it
me.
1/2 sine 2 alpha plus 2 beta?
Yes. Correct. So after that you can find the range of it, right? What's the range of that?
Minus 1/2 to 1/2.
Correct. Because sine of anything is minus 1 and then 1/2 multiple.
Yeah.
Okay. Now, finally, some last things. Then this chapter should be over.
Mm-hmm.
So now we have to study about conditional identities. Conditional. That means some condition is applied. That condition is actually a plus b plus c is pi. That means these are forming a triangle. So sigma sine 2a is. Oh, these questions are even like can be summed up with vectors, but they won't do all of this. Sine 4 sine a, sine b, sine c. Sigma sine a would be 4 cos a by 2 cos b by 2 cos c by 2. Then sigma cos 2a would be minus 1 minus 4 cos a cos b cos c. Okay, then sigma cos a would be 1 plus 4 sine a by 2 sine b by 2 and sine c by 2. Okay. Then also sigma tan a is equal to pi tan a. That means tan a plus tan b plus tan c is tan a tan b tan c. Then sigma cot a cot b. That means cot a cot b plus cot b cot c plus cot c cot say a is 1. Then sigma tan a by 2 tan b by 2 is also 1. And sigma cot a by 2 is pi cot a by 2. Okay, that's it. Oh, also, mm, if you have this, right, this can also imply that a plus b plus c is just not just pi, but some could be any integral multiple of pi. Okay, because we know tan of n pi is 0 because sine of n pi is 0. From there we derive this thing. And in fact, it simplifies for this too. Okay. And what would these two imply? Sorry, what these two would imply that a plus b plus c is odd times pi. Okay, not just any integer times pi, but odd times pi. Okay, so first four are for a plus b plus c is pi. Next two are for a plus b plus c implies is equal to n pi, and then next two are for a plus b plus c is some odd multiple of pi.
Mm.
let's say we have a plus b plus c as 2 pi, and we know that sine 2a plus sine 2b plus sine 2c is k times of pi sine a. Okay, that means sine a, sine b, sine c. So what is the value of k? Okay, let me solve. So 2a, 2a, okay, okay. What can we do? We can, I think, do one thing. We can write a plus b as 2 pi minus c that we generally do in here. Or we can do one thing. Yeah, we can do one thing. See, remember we studied this for a plus b plus c is pi? But here we are having a plus b plus c is 2 pi. So don't just use this thing, right? But maybe we can use this thing after some manipulation, which is that let me try to write a as, let's say, some basically x. Um, mm, okay, see, we know a x plus y plus z is when if this is it, so we know sine 2x plus sine 2y plus sine 2z would be 4 sin x sine z, 4 sin x sin y sin z. This is case insensitive. Okay, so I can replace x with pi minus a, y with pi minus b, and z with pi minus c. If I do that, would what would I have? If I like now, if I add it, so would I have x plus y plus z as 3 pi
3
minus
pi
a plus b
minus,
plus
yeah.
c, right? And a plus b plus c is 2 pi
Yeah.
here if you see. So that means x plus y plus z is pi. So I got what I started from. But you know what is that telling me? That is telling me that now I can even use it on this. Once I have basically written x as a. So we'll be like extrapolating our formula. So now I can write this as, how should I write? Um, wait. Wait, could you explain again? I think I've gotten confused. Okay. See, we cannot apply.
Oh, wait, let me just.
Wait. Hmm.
Case 4. Yeah, case 4, right? I think I got it, yeah.
Hmm. Okay. See, I did this thing so that I could show that I can still use my that identity, or okay, forget that. Uh, I get this as pi, right? So that means now I can replace it with this and I can do something. So if I replace x with pi minus a here, yeah, sorry, here, so I'll have okay, sine 2 pi minus 2a, which is sine, which is minus sine 2a. Then similarly minus sine 2b minus sine 2c, and that would be equal to, because x is replaced with pi minus a, so that's still sine only, right? So 4 sine a, 4 sine b sine c. Okay. So what does my k become now? Does it become minus 4?
Yeah.
Hmm. Basically, I modified my question to this, and then I tried to prove that I can basically use this thing only. I have, but just that I have transformed the argument, so now it becomes minus of 4 instead of just 4. Okay, can you try this question?
Yeah. Sorry, my mom was saying something. She will come and go and tell me to solve it, sir, even if I am already.
Okay. This question is also using some very good thing, similar to what we did yesterday. Something we did.
Sine 2 pi plus 7, sine 4 pi plus 7, sine 8 pi by 7. Okay. Is this like... I would first convert 8 pi by 7 into something like a proper fraction. So that would be sine 2 pi by 7 plus sine 4 pi by 7 minus sine 6 pi by 7. Yeah.
You said sine 6 by 7 is the answer.
No, I said no. I did not say that.
Okay. So what we can do is let this be x. Now,
I
you
think...
know. Hmm,
No, wait. I'm almost there.
okay. Where are you?
I'm getting... I don't know the exact value though. I think it's root 7 by 2.
Okay. Root 7 by 2.
Yeah.
This is how much?
Root 7?
Yeah, root 7 is approximately how much?
Root 7 is about 2.64.
Okay. Mm.
So it's 1.32.
So, okay. I think what you have got. Yeah, I think it's correct. Okay, but why did you? What do you get? Did you get an equation? Or okay, sorry. Okay, what I can do is let this be x. Then
Yeah.
these angles are differing by what?
I let it 2 pi by 7.
GP.
Yeah, GP.
So we can use something from here. Maybe we can use what? What should we use? Should we use
Sine
cos?
Ka, the sigma sine. I remember like sigma sine K is equal to sine n alpha by 2 into sine n plus 1 alpha by 2 whole divided by sine alpha by 2. That's what I did. So, and then I simplified the third term, right, to be sine minus...
That still don't improve. Because the same mistakes keep repeating, and no one tracks them. In exams, this turns into confusion and blank moments. With one-to-one mentoring, every mistake is corrected, and real improvement begins.